Okay, so we're talking about this concept of bounded above or bounded below, which is very easy, and it has to do with is there a ceiling or is there a floor to the problem? Okay, so let's say we are looking at this problem here. Let's say the red was its own separate problem without the blue. Okay, let's say the red was its own separate problem without the blue. So now you're asking yourself, is there a ceiling or a floor here? Okay, let's look right here. The answer is there is no ceiling, because eventually the red will cross the black, because this extends forever because of the arrowheads. Okay. However, we can also ask ourselves, is there a floor? Okay. Is there a floor in this problem? The answer is yes, there is a floor. The red never goes past the black. Okay, so because there's a floor, this is bounded. Okay, I'm gonna call this bounded. Okay, bounded below BB. Okay, at y equals to 4. Okay, at the horizontal line of y equals to 4, because remember, this black line intersects the y-axis, so that's why I call it y equals to 4. Even though it's a horizontal line, by the way, it's funny, people in AP Calc, they trip out on this sometimes, on this IM1 concept. This is a horizontal line, yet they ask, oh, Mr. Chen, why is it y equal to 4 then? If it's a horizontal line, shouldn't a horizontal line be denoted by x equal to something? I understand that logic, however, that logic is wrong. Okay, if it's a horizontal line, it's y equals to something. Okay, because the horizontal line intersects the y-axis. That's the key thing to remember right there. The horizontal line intersects the y-axis. Therefore, this is y. Okay, and conversely, as a side note, if it's a vertical line, it's x equals to something, because a vertical line intersects the x-axis. Okay. Now, let's go ahead and look at the blue graph now. Now we can ask ourselves, is the blue graph bounded below? Okay, is the blue graph bounded below? The answer is no, there's no floor. Okay, there's no floor here because the blue arrowheads cross the black line. Okay, so we can also ask ourselves, so it's not bounded below because there's no floor. We can also ask ourselves, is it bounded above? Okay, is it bounded above? The answer is yes, there's a ceiling. It never crosses the black. Okay, so in this case, we're going to say bounded above. Okay, bounded above at y equals to -3, like that. Okay, all right. I want to jump to the fourth example, okay, right over here, and show you a situation where it's not bounded by anything. Okay, there's no ceiling or no floor, and that's really easy. Is there a ceiling here? No, because this yellow arrowhead will cross the black. Okay. Is it bounded below? No, because there's no floor, because the yellow arrowhead will cross the black. Okay, so this one is, we're going to say, not bounded. Okay, NB. Okay, NB, not bounded. That's an easy example. Now let's go to this one right here. This is easy, like we just said. This is clearly bounded below. That's clearly bounded below. So we're going to say BB at y equals to -7. This is questionably bounded above. Okay, Now, this is actually, yes, bounded above. There is a ceiling because there are no arrowheads. Okay, if you don't see any arrowheads, you assume that it does not continue. It does not go on forever. Okay, so right now, the way it looks with no arrowheads is going to be bounded. Okay, it's going to be bounded above. Okay, bounded above also at y equals to -3. Okay, now if there were arrowheads here, then this is not bounded above because those arrowheads mean the graph continues and it crosses the black line. Okay, very easy. Hopefully it makes sense to you guys. Okay, last one. Okay, the third example. Okay, this is clearly, let's just look at the red graph. Okay, let's look at the red graph. This is clearly not bounded. This is not bounded below. There's no floor, okay? Because this yellow arrowhead will cross the black. However, let's look here. Is this bounded above? Okay. Now, the answer is yes, it is bounded above. Okay. The red gets closer and closer to the black, but it never touches the black. Okay, it never touches the black. So there's a ceiling. Okay. Now, how do you know that? Okay, well, Mr. Chen, how do I know that it doesn't cross? Just take my word for it for now. These are called exponent functions. When you see an exponent function, something that looks like this, okay, something that looks like y equals to 2 to the power x, you're going to get a graph that has something like this, a black line that comes close to but never touches, which is called an asymptote. If there's a line, okay, but it comes close to but never touches, it's called an asymptote. Okay, one of my favorite basketball players is Allen Iverson, and he came so close to getting an NBA championship, but he never touched gold. Okay, and that's what I like to think of, for better or worse, because it's kind of a depressing story of an asymptote. Okay, asymptote. Okay, it's a line the graph comes close to but never touches. So now we do have a ceiling. I'm going to put the ceiling in red so you know it belongs to the red graph of y bounded above at y equals to 2. Okay. Similarly, for the blue, we also have it is also bounded, but this time it's bounded below by a floor. Okay, so bounded below at y equals to -6. Okay. All right. So, I want you to go ahead and do these problems here. Okay. Load these up on Desmos. Okay. Load these up on Desmos. And go ahead and tell me whether it's bounded above or bounded below. Okay. Desmos is not going to show you the arrowheads here. Okay. But it's going to be pretty clear which ones go on forever and which ones don't. Okay. So go ahead and do that one right there. Okay. While I make this video.